Hi guys! Today we continue talking about Python decorators. This is a second video in 4-part series. So if you don't know what decorator is, or if you haven't watched my first video, please stop now, go and see the first video and then come back. Now, after I assume that you do know what decorator is, today we will see more complex examples of Python decorators. We will implement a couple of them together. You will see how to implement a decorator that works on function that receives parameters and returns values. In addition, we will see how to implement a decorator that receives parameters by itself. And then we will see how to put all this beauty inside a class. So it's gonna be fun. Let's start. So let's start from a recap of what we've seen in the previous part of our decorator series. So to remind you, in the previous part, we completed an implementation of a simple greeting decorator. Here, you can see it here. And just to remind you, this decorator intended to print some beautiful welcome message. Then it was supposed to run the original function, and then it was supposed to print some goodbye message. So this is again just the same decorator that you've seen in the previous part. I will just run it now to trigger the definition. And just to see how exactly it works, I implemented here a small standard function that's called sum of digits. And as you can understand, it calculates the sum of the digits of a number. So the function gets the number as an input, and then it calculates its digits and prints the result. So let's run the definition of this function as well. And look, now if we just run this sum of digits function, it will ask me to enter a number, which I will do. And then I will see the sum of its digits, which is 13 in this case. Now, if I will define the same sum of digits, but now with greeting decorator, okay, you see the content of the function is actually the same. And this time, if I will try to run the sum of digits, I will first see this welcome and hello message. Then it will ask me to insert a number. Then I will see the sum of digits, and then our greeting decorator will make sure that the beautiful goodbye message is printed out. So how did it work? So to remind you, when we define our function and when we decorate it with our decorator, the actual function that is being defined by Python is not this code, the actual code that has been pointed to by sum of digits identifier is not this code, but actually it's the code that is returned from here, right, from the decorator. So sum of digits is becoming this actually greeting function that first prints something and then runs the original sum of digits and then prints the goodbye. Now you have probably noticed that my original function, this sum of digit, is defined, I would say, in a bit weird way. And it's defined in a weird way in the sense that instead of passing this sum of digits, a number as a parameter, and instead of returning the sum as a return value of the function, I get this number as an input from the user and I just print the sum. Now, it was done intentionally just to simplify our first and basic decorator. But now, after we know what decorator is and how to write the simple one, we can actually move forward and see how we can define a decorator that can be suitable for any type of function with any parameters. So Let's start, first of all, with redefining our sum of digits in a more normal way. So the code inside it is almost the same, except for the fact that the number is now provided as a parameter and the sum of digits is now returned as a return value. So let's redefine this function and let's just check it with, for example, number 273. So I get the sum of digits, which is 12. And now, if I will try to define this new sum of digits with our original greeting decorator, and if I'll try to actually run it, this sum of digit, I will actually get an error, okay? And the error says, greeting func takes 0 positional arguments, but 1 was given. Now, let's try to understand the meaning of this error. So first of all, error is talking about greeting func. So what is this greeting func? And I want just to remind you that greeting func is actually this function, this one, returned from our greeting decorator, right? This is why we implemented this decorator at the first place. And indeed, when I look at the parameters of the greeting func, I see that indeed it receives no parameters. And that's why we see this error that says greeting func takes 0 positional arguments, but 1 was given. Okay, so just to remind you that when we define our sum of, when we decorate our sum of digits with this decorator, what actually happening here is that Python interpreter does the following. It says, okay, I see that there is this sum of digits identifier, but it is decorated with greeting decorator, which means that it replaces the original sum of digits implementation with implementation returned by our greeting decorator, and the function that is being passed to the decorator as a parameter is actually our sum of digits, okay? And the thing that is being returned by this expression is actually our greeting func. And just to remind you again, our greeting func is this one, and it receives no parameters. So we can understand from here that probably we need to rewrite our decorator somehow to support this sum of digits function. And let's try to do this. So first of all, we say that this greeting func now should accept a number, right? And then we should actually pass this number to our original function. And I remind you that this other func is actually sum of digits function that is being passed to this greeting decorator. Another thing that was missing in the original greeting decorator is a returning of the result of our original function, which is sum of digits, right? Because if we will not return this result, then our sum of digits, which is being overwritten by greeting func, will not return anything, and this is not what we want to achieve. By using decorator, we want to achieve actually the same signature and the same return values as the original function that is being decorated. So let's redefine this greeting decorator again, and let's just try running it, defining it again with our sum of digits function. And now let's try running again this sum of digits. So let's do it. And as we can see, now everything runs clearly. So first we see this hello message, and then we see this goodbye message, no errors, and we also see that, right, there is the return value that is being returned from the original sum of digits function, and it is 12. Okay. There is one step left to make our greeting decorator or any other decorator quite perfect, and to make it usable for any purpose. And the fact is that now we implemented our greeting decorator in a way that actually requires us to use this decorator in decorating functions that receive one single positional argument and returns some value or values. But the fact that now I decided to use this greeting decorator with our sum of digits function, this fact doesn't mean that tomorrow I won't like to use it with some other function, and maybe another function will have less or more parameters, or maybe it will have keyword arguments, etc. So as you can see, currently our greeting decorator is not implemented in a generic way that allows us to use it with any function. So our last step is actually to rewrite our greeting decorator in a more generic way, and Python allows us to do it very easily using its star args and star keyword args signature. Just to remind you that this signature, this star args, means that it can receive, that greeting func can receive any number, including 0, of positional arguments, and star keyword args means that we can also, our greeting func can also receive any number of keyword arguments. So, by the way, this signature also includes the case when we have no arguments at all. So, just by rewriting our greeting func in this way, that kind of says, okay, any amount and any types of arguments can be passed to this function, and then calling this original function with the same arguments, provides us with generic greeting decorator that actually can decorate any function in the world. So let's try to redefine it again. And now just to make sure that it works, I define here a new function called sum and if. It receives 2 positional arguments, you see, num1 and num2, and it also receives 1 keyword argument. By the way, this is a really simple function. It just returns a tuple of sum and a difference of the first positional arguments, and if the verbose keyword argument happens to be true, it also prints out the result. So let's now see that after I define this sum and diff function, and after I decorate it with our greeting decorator, I can actually run it, and it runs without any problem, even though, you see, now I intentionally provided it a couple of positional arguments and also 1 keyword argument. So just to summarize what we've seen now, if you want to implement a decorator that will, in the correct way, if you want to implement a decorator that will work with any function, here is the template for doing it. So you create your decorator. It should receive some other or original function as an argument. Now inside it should define a new function which actually will replace your original function, and then you should not forget to return this function you are defining. Now, to remind you, when defining a decorator, you must make sure that the signature of the function, of this function that is being returned from the decorator, is exactly the same as the signature of the original function that is being decorator. And we can achieve this by including these star arcs, star keyword arcs keywords in our signature. So just always remember to put it this way. Then, optionally, you may have some code that runs at the beginning before you call the original function. Then, probably somewhere in your code, you must have this call to your original function, right? Because otherwise, you're not decorating it, you're just rewriting something totally new. And here it's important not to forget to pass the received parameters to the original function and to store the result in temporary variable. Then, after you run this original function, you might want to run some additional code that does some stuff. And then, in the end, another important note, do not forget to return the result that came out of the original function. And that's it. So this is your decorator template. If you want to implement any decorator in the best possible way, just use this template and it will suit all your needs. So now, after we talked about a more advanced decorators, it's a time for a little exercise, and I will now present it to you, and I will now explain you what you should do here. But before I continue, I want to encourage you to try and solve this small exercise before you continue watching this video, because the next parts of this video will contain the actual solution of this exercise, and I really encourage you to try and solve it by yourself before you go to the solution. So the exercise is as follows. I want to ask you to implement a decorator named performance log, and what this decorator should do is as follows. It should run the original function, and after the original function finished to run, this decorator should display the amount of time it took for the original function to run. Now, this kind of decorator might be very useful if you want to debug or to profile your code to understand why it runs slowly, whether there is a room for improvement of your code, etc. And so, as an example, I provided here this function which is called long-running func. It doesn't do very interesting stuff, but it just receives some number and another number, which is amount of iterations. And as you can see, it just the function just performs this multiplication many times, amount of times that is provided as iters. Now, if you increase this number, these iters, this function might run a very long time, and we want to test it, we want to see it. So your exercise here is actually to implement this piece of code that will allow us to run a long-running func with various inputs like this. Look, you see, like this. And we want to see, in addition of the return value, we want to see a message that will actually come from this performance log decorator. We want to see a message that says how much time it took for the function to run, or the execution time of the function. And just one hint before you start solving this exercise, you can try using this time perf counter function of a time library. It's very useful. It returns you the current time, and you can also So you can run this function before, you can run this perf counter before you run the original function, then after you run the original function, and the difference between the times, between the end time and the start time, will actually provide you amount of seconds it took to the original function to run. So if you want to try and solve this exercise on your own, please pause this video now, and after you finish, we will continue to the solution and to our next features and properties of the decorators. Okay, so now I'm going to talk about the solution of our performance log. As you can see, I define here our decorator. Again, it defines a new function that receives any possible parameter. At the beginning, before I run the function, I store the start time. Then I run the function and store the result it returns. Then I measure the end time, and the execution time in seconds is actually end time minus start time, and that's all. So let's see how it runs. I will just decorate my long-running func with this performance log. And here you can see that after I run this long-running func with different amount of iterations, first of all, you can see that the output is an extremely huge number. But the more interesting part is this execution time in seconds that you see. And the execution time in seconds is smaller for smaller amount of iterations as expected, right? You can see that when I increase my iterations, I get longer execution time. Okay, so we saw it, and actually now I would like to improve our performance log decorator a little bit. And using this example, I will also show you how you can implement decorators that by themselves receive some parameters. From presenting of what do we want to achieve. And as you probably have already seen, our performance log logged the execution time of the function in seconds. Okay, so this number is actually, its time units are seconds. Now, I want to be able to provide my, my performance log decorator a parameter that will define the time units in which I want to log the execution time of the function. Okay, so I don't want it to always be seconds. I want to be able to define it either as seconds, milliseconds, or nanoseconds. So first of all, let me show you how I want it to look like. And I would like to be able to write something like this. You see, like to call the performance log with this time units parameter. And then I want to make sure that if I define this decorator with time units as milliseconds, the message about the execution time will actually be in milliseconds and not in seconds. The same here, example for nanoseconds, you see, so I want to achieve the same implementation of performance log decorator that will allow me to define it for some functions with, let's say, milliseconds, and for other function to define it in nanoseconds or any other time unit. And in order to see how it can be achieved, let's first of all remind to ourselves what exactly happening when a Python interpreter defines a function, one of these functions that is being decorated. So just to make sure, we know that, let me just delete it for a second and we will rewrite it again. So we know that if, for example, our Python interpreter walks down and reads this code it sees the definition of this long-running function, but it also sees that there is something decorating it. And we already know that this decoration is actually should be written before the definition of the function itself. What I mean? So if we look at our initial definition of this function, in this case, we know that the Python interpreter will write something like this, right? And it will provide our original function here as the parameter for this performance log, right? And then we know that this thing will actually return a function. Now, if I will just return the original writing that has been here, we see that in this case, now, instead of calling just performance log, the string that appears after this at symbol is actually this one, right? So what I will do now is I will just copy and paste it here, okay? So what we know now is that our Python interpreter, when it sees this kind of definition, it will call this performance log function with the parameters we provided, and then we expect that calling this function should actually return us a function, right? Because we want to make sure that this thing that is written here is actually the function that can receive another function as a parameter. And by the way, what is the return type of this whole thing should be? It still should be a function, right? Because we are rewriting our original function with a new function. So the return type of this should be a function. So in addition, we also know that a return type of this should be a function that receives another function as a parameter and returns a new function. So let's see how we can define it now. And currently I will show you just some kind of template definition, and then we will fill it up with the actual code. So we said that calling the performance log should return us a function. Okay, so just to start with, first of all, we want our performance log to be able to receive a parameter. Here it comes, just right here. And we want our performance log to create a function here. You see, this is the definition of the function. We want it to create a function, and of course, this function wrapper, in our case, it should also be returned from the performance log. But we also have another requirement from this function that is being returned from here. And this function should receive as argument another function, okay? So it gives me a hint of what should be the parameter here, the signature here. Another thing that we should implement here is we said that this function that is being returned from here, it should receive a function as a parameter, and it should also return a new function, right? That somewhere inside it runs this original function. So we said this is the function that is being returned by performance log. And we said that there are two requirements from this wrapper function. The first one is that it should receive another function as a parameter. And the second requirement is that this wrapper function, again, this is what returned from here, it should return a new function as well. So in order for wrapper to be able to return a new function, it should define one, right? So here we are defining this new function. Currently, again, there is no real code here, but we define this function and we return it just here. And as you have already probably noticed, we kind of added here just one extra level of function definition, just because this performance log is the return value of this thing is a function that once used to be our original decorator. So you can see that this part, is kind of template that we used to use for implementing our decorator that does not receive any parameters. And that's why, by the way, we also have here this signature to make our decorator generic. So now, after we've seen it, let's, as I said, it's not the actual implementation of our new performance log, but just a template. But now let's try and implement it. So look, you see the template of this decorator is the same. So I have like a function definition inside function definition inside function definition. So 3 times def. This is what you see here as well. And just make sure that you understand the actual implementation. So now we get these time units, and the value of time units can be either S for seconds, ms for milliseconds, or ns for nanoseconds. And here I just check if the time units is nanoseconds, then I don't use this regular perf counter function, but I use perf counter ns for nanoseconds function that is able to calculate current time in nanoseconds, which is a very, very kind of high resolution. And then again, I have this logging of the beginning of the initial time of my original function, then I call the original function, and then I log the end time of running of my original function. And then another check, if we want to display time in milliseconds, then we just, and as we know, a perf counter returns us a time in seconds, then we just want to multiply this execution time by 1000, which will give us milliseconds. So again, take your time if you need to review this code to make sure you understand it. And let's just run it now. And now let's try and define our long-running function with a performance log in milliseconds, for example. So you see now, if I will run it again, we will get that the execution time is 0.3. Now, look, if I will change this implementation, for example, for something like this, and if I will try, if I will ask to log our execution time in seconds, then when running this function again with the same parameters, you see I will get almost the same number, but it's now in seconds, you see. Here, these 3 leading zeros. By the way, why it can be useful to be able to run this performance log decorator with nanoseconds, for example. So it can be useful if you want to measure your execution time for functions that usually don't take much time to run. So you kind of need a higher resolution here. You need to be able to count actually nanoseconds if you are doing a profiling job now. And just as an example, again, if I define another function, sum and diff, with other parameters, and I ask to log its execution time in nanoseconds, here you can see that I get this execution time of 2005, right? So it's 2005 nanoseconds. Okay, so we've seen now how we can implement even more advanced decorators that include decorators that are capable of receiving parameters and arguments by themselves. And one last topic that I would like to discuss with you and also to provide you another exercise is I want to discuss with you implementing decorators inside classes. So maybe let me start from an example when and why you would like to do such a thing, and I think it will become quite clear. So let's say I have this bank class, and the implementation of the methods inside this class is not very important here, but their signatures and definition of the methods is important. So I have this bank class, and it represents some bank. So I can initialize it with some bank name, let's say. And in this, I have 3 methods inside this bank class here. The first two methods, withdraw and deposit. As you can understand, withdraw it's actually allows us to withdraw some amount of money from the account, and deposit can allow us to deposit some amount of money in the account. And these 2 methods are critical methods. So since they are critical, I want to make sure that these methods are called only inside working hours of our bank. Okay? I want to make sure that no one can call these methods while outside of working hours. Now, why would I like to do this? Well, let's say these are critical actions, and if there is some problem, I want to make sure that there is some company bank representative who can tackle this problem and fix it or something. And in addition, I have a third method in my class, and it's called feedback. And this is a non-critical method in a way that, as it says, feedback just allows my users to provide some feedback for the service they are getting from my bank. And, even if something goes wrong during this feedback functionality, I can live with that. I don't really need a representative to physically be at work to handle some problems if they occur. And that's why I want to allow running this feedback method anytime, including outside of working hours. So in this case, I really would like to implement a decorator called working hours only. And as you can probably understand, I would like to decorate using this decorator functions that are critical, or those functions that should run and must run only during working hours of my bank. Now, your exercise will be to actually implement this decorator that makes sure that this callable, that method it is decorated, it decorates, will only run Sunday through Thursday between 9 a.m. and 5 p.m. But one thing I want to mention here before you will start implementing it is that even if you define your decorator inside the class, and I think that here you can see why it is very, it does make sense to implement it inside the class, because the logic of this decorator is tightly coupled with what my class is doing. But one important technical detail that you should know is that while defining decorator inside a class, it does not receive this self as an argument, okay? Just make sure that you don't somehow add this self as a parameter here, because it will not work. And it happens because, think about it, this decorator is actually kind of static class method, right? Which does not make sense to pass it this instance in named self, because this decorator actually runs only during the stage of class and class method definition. So we never want to actually pass some instance, right, some self to this decorator, right, because the code of this decorator should only be influenced by the function itself, yeah, by the method itself, and not by some instance. So this is the technical detail I wanted you to know, and it's that when you define a decorator inside the class, make sure you do not provide here this self parameter. Okay, so I think now you are able to implement this decorator, and let's say that what it should do is as follows. It should, first of all, check when the method, when this callable is being called. If it is inside the working hours, then it should just call the original method, that's all. Otherwise, if the method provided here is not called, is called outside of working hours, we want this decorator to throw an exception, right? And you must make sure that the original method is not called in this case, right? So it will mean that if I call, let's say, withdraw method on Saturday, this message should not be printed, right? And the withdraw method should not be called. I just should get some exception that says outside working hours or something like that. So here you have just some output examples, some examples of how I would like to call this method. So you see, you can check, you can test your code with these 3 lines. And if, for example, you call this during Saturday, this line actually will always work. This one will work as well. And this line, for example, should throw an exception if you call it outside working hours. So I really encourage you to try and solve it. Though you also have a solution here, I will not show it right now, but you have the link for this collab in the video. So if you want, of course, you can check the solution, but really try and solve it by yourself. And as the bonus exercise, I can suggest you now to try and implement this working hours only decorator in a bit more advanced way. And given the fact that we have already learned how to implement decorators that receive parameters by themselves, I encourage you to try and implement the same working hours only decorator as here, but implement it in a way that will allow you to pass working hours as a parameter here. Okay, which means it will give you flexibility to define this decorator with different working hours for different critical methods. So it's not a very hard exercise, but it will kind of remind you how to implement decorators that receive arguments by themselves. Now, I do not publish any solution for this exercise, but I do encourage you to try and solve it. And please publish your solutions in the comments of this video. I will be glad to see it and to review it. And also add your own additional comments if you have. I will be happy to look at them and to take them into account when recording my next videos. So, you've seen a couple of examples for advanced Python decorators. We actually implemented them together. I hope that these examples raised a couple of ideas in your mind on how you can improve your own code using decorators. So if this is the case, Don't wait, go now and write your own decorators and try to make use of knowledge you gained here in this lesson. I also encourage you to continue watching my next lesson, part number 3 in this series, where we will talk about concatenation decorators, which means we will see how we can define a couple of decorators on one specific function, and we will see how it actually works. So, see you then!